What's going on, guys and gals? Today we're going to be talking about triangles again. So we're kind of looping back around, sticking with shapes, but we're going back around to our triangles again. Except we're going to be looking at something a little bit different with some like classifications and measuring of angles and things. So there's a little bit of review on this, and there's a little bit of new. So just show you what we got. We're going to get right into it here. Just some things to know. You can always go back and refer to this video if you need to take notes in your notebook. That would be fantastic. But you can look here and it says that a triangle in plane geometry is a closed figure that has 3 line segments for sides. All right, the sides meet at 3 points called vertices, and each vertex forms an angle with 2 of the sides. All right, tri meaning 3. Here's your symbol for triangle. So down here you can see we have A, B, and C. You have the vertices here, A, B, and C. And you have 1, 2, 3 line segments. So you would write this in any of those ways would be acceptable. It doesn't matter what order they are in, but you can write it any which way you want. You can also pick out angles. Okay, so the angles are named with the letters inside, sides, excuse me. So if you look here, you've got angles ABC, ACB, CAB, and so on. Okay, and you can just keep going with that. Let's see, let me move on down. Now, kind of what I wanted to talk about a little bit today was the measurement inside of the angles, like the overall measurements. And so what we're going to look at is you've got your 3 angles here, and they give you the angles for the 2. Now read right here. You can figure out an unknown angle in a triangle if you know the measure of the other 2 angles. The sum of all the angles in a triangle is 180 degrees, okay? You can use addition and subtraction to find the unknown angle. So this angle plus this angle plus this angle has to equal 180 degrees. So that means that if we know 2 of the angles, we can figure out the third, okay? So in this case, we had 95 and 30, all right? And we need to find what the measure of MKL is right here. Okay, so that's what we need to figure out. So you got to add the 2 unknowns, which they added for you, 95 and 30, to get 125. You're going to take that and subtract it from the total amount that it should be, which is 180. Okay, if you do that, you're going to get, and I cannot write with this thing, 55 degrees. Ooh, I'm a little dot. 55 degrees, all right? So that is your unknown angle in that case, okay? Piece of cake, right? So really all you just need to know is that they're going to have to equal up to 180 degrees, no matter what, okay? So let's move on down. I want to try to keep these as quick as possible. I don't want you watching videos for 15 minutes or listening to me talk. So you can see here now they're going to classify them with the acute, right, and obtuse. Now we know that triangles can be classified based on 2 different things. They can be classified based on the measurement of their angles. They can also be classified by the length of their sides. So this is strictly on this, in this case, just the angles. So it's acute, right, obtuse, and you can see, hold on, sorry. You can see here that you have 2 acute angles. You actually have 3 acute angles here. These are all less than 90 degrees, okay? Down here you can see that there's a right angle, which means that one's going to be 90 degrees, okay? And then over here you can see we have an obtuse angle, 130 degrees, okay? So if one obtuse angle means an obtuse triangle, okay? All right, let's look at triangles named by the length of their sides again real quick. We'll just kind of review that. An equilateral triangle is going to be one that is measured with all the sides equal, so you've got 14, 14, and 14. This would also be an acute triangle because those angles of these vertices are less than 90 degrees. So this is an acute equilateral triangle. All right, if you go down here to isosceles, that means that 2 sides are equal and then 1 is not, makes it isosceles. Okay, and then the scalene triangle is where all the sides are different lengths. You got 9, 3, and then 10 and 6/10. All right, so here's what we're going to do. Today, I'm going to post this, I'm going to pull this sheet out by itself, and you guys are going to complete this on a Google form. So you're going to look at the worksheet and just write your answers in on the Google form. Okay, so I'm going to post the video and this sheet right here. Okay, and then on another assignment tab, like another assignment thing, it's going to have just a blank Google form with 12 blanks. And it's going to say identifying triangles, and then you're just going to put your answers for all of these onto that. Okay, so for example, what is the name of this triangle by the size of its angles? So it's not going to be equilateral because it wants to know based on the size of the angles. These are less than 90 degrees, so number 1 would be an acute triangle. Number 2, what is the name of the triangle with the length of the sides? Well, these are all equal, so therefore it's going to be an equilateral triangle. So it's an acute equilateral triangle. Okay, so number 1 acute, number 2 equilateral. So I've already done the first two for you, and it just wants you to classify all of these triangles based on their size of their angles and the length of their sides. Okay, so do that for me, and that is going to be it for today. Have a good one.